So we started chapter 3 already last semester, chapter 4, sorry. And chapter 4 started writing the equations of lines. I gave you 2 points, or I gave you a slope and an intercept, and we were then able to use slope-intercept form to write the equation. Today, we're going to introduce a different way of writing an equation of a line, and that is point-slope form. And point-slope form, guys, is this thing right here. This is one of those things that's very important that you guys know, you remember, because I think it's pretty easy to use. I think this is easier than using slope-intercept form. Remember, for slope-intercept form, you needed a slope, you needed an intercept. Okay, sorry, let me backtrack on that a little bit. If I was given a slope and given an intercept, a y-intercept, then yes, slope-intercept form, plug in M, plug in B, you're done, you're happy, it's real easy. But if I was given 2 points, or a point and a slope, using slope-intercept form, where I plug in an x and a y and an m to solve for b, takes a little bit of time, takes a little bit of thinking, because you solve for b. Some people say, hey, there's my equation, b equals 5. No, that's your y-intercept is 5. You need to rewrite the equation. The cool thing about using point-slope form is that if I'm given a point and a slope, or 2 points, because I can find slope, if I plug it into y minus y1 equals m times x minus x1, and I plug in the point x1, y1, or the point as x1, y1, and the slope for m, like normal, all I have to do is plug it in there, solve for y, and I'm done. Well, all of our equations have always been y equals, y equals, y equals. So that's what we're trying to get at. So therefore, that's what I would use. So our first example, it says write and graph. So now we have to go back into earlier stuff, graph the equation in point-slope form. It says write the equation in point-slope form for the line that passes through -2, 1, with a slope of -6. Then graph the equation. Now there's a couple different ways that we're going to do this. So, first thing it wants to do is write it in point-slope. Notice that it's not write the equation in slope-intercept form. I want it as y minus y1 equals m times x minus x1. So I need to write it down. If I'm going to use it, I will write it down. Y minus y1 equals m times x minus x1. The point -2, 1 is my x1, y1. So maybe I'll put x1, y1 with it. And slash -6, I'll put m underneath there so that I know all of my pieces, where they go. Happy. And so, start filling it in. Y minus, what's y1? 1 equals, what's m? -6 times x minus -2? Oh man, I got an extra set of parentheses in there. Let's get rid of those parentheses. Here's the thing. I'm going to get rid of the extra parentheses, and I'm stopping. Which means y minus the parentheses of 1. Do I really need the parentheses on the 1? No. So, we can say, hey, that's just y minus 1 equals -6 times, what happens when you subtract a negative? You're adding, right? So it becomes +2. Guys, that right there is where you stop. You stop and you say, hey, this is point-slope form. So when it says write it in point-slope form, you stop there. Now it wants you to graph it. This is where you have a couple options. Just like there's a couple different forms of writing an equation of a line, you now have a couple ways you could graph this. A lot of us really like slope-intercept form when graphing, right? So that means I could take this equation and I could change it to slope-intercept, which means solve for y. To solve this for y, take the negative 6 and distribute. So you get y minus 1 equals negative 6 times x. Negative 6x. Negative 6 times 2 minus 12. And then you get y by itself. It's y minus 1, so therefore just add 1. I'm going to squeeze it onto the bottom here. Plus 1, plus 1. So one option is to change it to slope-intercept form, which is y equals negative 6x minus 11. You guys okay with that? I just switched from point slope to slope-intercept form. Going the other direction, it's a little bit trickier. Most of us probably wouldn't be able to do that, or we wouldn't do that. But we do like to write from point slope to slope-intercept. But now if I ask you to graph this, you start where? Yeah, Fritz. 0, negative 11. Y-intercept's at negative 11. And then do what? Rise over run. What's your rise? It's negative 6. So I actually go down 6 and then over 1, over to the right 1. Or I could actually do what? I could go up 6, but then go back 1. This graph is going to be not the best looking, right? So I'm going to go by 2s. 2, 4, 6, 8, 10, 12. Is everybody okay with that right there? So I have to go down 6, or I can go up 6. If I go up 6, that's 2, 4, 6, but then go back 1. Let's go by 2s as well here. So 2, 4, 6. Be about here. It's a pretty steep line, isn't it? Mm-hmm. It's a negative, so 2, 4, 6, somewhere about there. There's your line. Is that the only way we can do this? No. So that's one way that we could graph this. Switch it to slope-intercept form. Everybody's happy about slope-intercept form. We've done this many times. I'm going to change colors. I'm going to use the exact same graph. Let's use orange. What if I use the point and the slope instead? What if I actually use the point-slope form? We said that this box was point slope right here, right? Y minus 1 equals negative 6 times the quantity x plus 2. What was the point that we used there? What is the point? Negative 2, 1. What's our slope? It's negative 6. If I am given a point and I'm given a slope, can I graph in a line equation? Yes. How do you do that? You plot the point and then get to move slope. Negative 2, 1. Isn't that right there? And now I can go down 6 over 1. Oh wait, down 6 over 1. Isn't that the exact same points? Just happen to be. Sometimes they're not the same points. They're just points that are on that line. So, two different ways here, or two different ways to use what we have for writing equations. If we're given a slope in one point, I am now going to substitute the value of m and let the x and y coordinates be x1, y1. That's what I said. And substitute that m, x, and y into the slope-intercept form and solve for b. That was what we did in 4.2 or 4.1. I can't remember off the top of my head. It's been a while. rewrite the equation in the right form, right? That was the very first thing you did. You plugged in for x, the y, the m, solve for b. That's solving using slope-intercept form. The second one is if I give you 2 points. You find the slope between those 2 points. You choose one of those points to use, and then you can follow the steps from before, or you can use point slope now. So this is your choice now. Y equals mx plus b, or y minus y1 equals m times x minus x1. Both of these will give you an equation of a line. Now, I'm going to tell you this right off the top of your head, off of my head. If the directions just say, write the equation of a line, then all of your answers better be in slope-intercept form, which is this one. You can use point slope to get there, like we did in that first example, but the answer should always be given in slope-intercept form, because that way we know it's a line, we can see it's a line, we can see a slope, and we can see a y-intercept. Very critical points for a line, easily done. Okay? Any questions? So, actually we already did this, so I'm going to let you guys try this on your own. I want you to change this to point slope form. Not point slope, this is point slope form. I want you to change this to slope intercept form, which the book is calling standard form as well. My bad, not slope intercept form, it is standard form. I want it in standard form. Maybe before I cut you guys loose on this, what is standard form? Yeah, it's ax plus by equals c. Where there was a couple conditions, a, b, and c, which are the coefficients, have to be what kind of numbers? Not all positive, but nice. It means whole numbers. And a, which is on the x, has to be positive. Okay, so try that. Think about how you could do that. First day back, everybody still sleeping? Fritz? Yeah, distribute the 7. So y minus 1 equals? Everyone? 7x plus 35. Remember, standard form says x's and y should be on the same side. A, or the x's should stay positive. So what should that tell you about the 7x? Is it going anywhere? No. The y's do need to go someplace. Where do they need to go? To the other side. So to get it to the other side, I will subtract a y. But that means I got to also get rid of what? The 35. And so I'm going to subtract 35. What's negative 1 minus 35? Negative 36 equals 7x minus y. Standard form. Now, could I have also written this, guys, as 7x minus y equals negative 36? Yeah, it's the same thing. Wait a minute. Couldn't we graph it from here as well? I'm not going to, but wouldn't I just set up going to the eye doctor using cover up? If I cover up the x's by plugging the 0 in, y is equal to what? 36. If I cover up the y because I put a 0 in, x would have to equal negative 36 over 7. Comes out to some decimal. Is that okay? Can you plot those 2 points? Can you connect them with a line? I would hope so. So we can graph it. Notice that at this point as well, here, or here, it doesn't matter which one of these, I could have you switch it to slope-intercept form as well. And then we could graph it from there. You'll end up with the same line every single time. I think there's one more problem. You ready for it? Put it in slope-intercept form this time. Try it on your own.
Okay,
Here you go.
ready, buddy.
Oh. Okay. You're recording. Tell us what you're doing.
Well, I'm distributing the 3 into the x and the negative 4. So it would be... And then you would minus the 6 on both sides.
Thank you. Guys, see how much easier this is, potentially, of writing in slope-intercept form, giving your equation. Really, it's just distributing, getting the constant that is with the y to the other side, and you're done. Can you tell me the slope? What's the slope? Slope is not 6. M equals negative 3. Your y-intercept is 6, or we'll even say 0, 6, because I like it as a point. Are there any questions, guys? So today's about converting. Yeah. Homework is page 235, 1 through 10, and 59 through 71. Have a great day.